exploration of complex numbers dates all the way back to the year 750. However, Girolamo Cardano, an Italian mathematician, was the first to publish the formula for complex numbers in 1545 as a way to solve cubic and seemingly unknown quadratic equations. But what are complex numbers? I'll have Felix explain.
Alright, in the math world, there are numbers like real numbers, which are numbers like 2, 2.3, 2 squared, pi, right? And then there are imaginary numbers, which are numbers that can be represented like this, right? So I squared equals -1. There's no possible real number you can plug into I to make it equal -1, right? So that's why these are imaginary numbers, because only those numbers could give you this outcome, right? And then to make a complex number, you add real numbers and imaginary numbers to make one equation. And that's how you get a complex number, which would probably look like this, right? So A equals 3 plus 7i, right? The 7i is your imaginary number, and the 3 is your real number. So all together, you get a complex number. You can also graph these complex numbers. For example, 3 plus 7i would look like this. Alright, so the y-axis is where all the imaginary numbers would lie, and the x-axis is where all real numbers would be. So the real number in this is 3, and the imaginary number in this is 7. So you would go to the right 3 because you have the real numbers on this side, and you would go up 7 because you have the imaginaries on that side. So if you go to the side 3 and go up 7, that is where you'll be. Another thing you can do with imaginary numbers is you can add them. So for example, it's just like adding like terms. So you could do 3i plus 2i is 5i, so then you have 5i plus 2 and 2, then that's plus 4. See? So it's just combined like terms. You can also subtract them. So 3i minus I would equal 2i, because I is the same thing as -1i, right? And so then you just have the 2 and 4, and plus 2 plus 4 is plus 6. So yeah, it's just like combining like terms.
We can even multiply our complex numbers. So for instance, we have 3 plus 7i times 2 plus 3i. So how do we solve this? All you have to do is distribute. So you could do FOIL, which is first 3 times 2, which is 6. Then outside 3 times 3i, which is plus 9i. Then you could do the inside, which is 7i times 2, which would be plus 14i. And then last, 7i times 3i, which would be 21i squared. The next step was just to combine like terms. So I got 6 because you just have to leave the 6 by itself. It can't be added to anything else. I got the 23i by adding 9i plus 14i. And then instead of leaving 21i squared as it is, I replaced the I for the square root of -1. The square root of -1 is the same thing as I because it represents the imaginary number, since there's no number that can give you the square root of -1. The next step was to simplify. So you still have 6 plus 23i, and now you just have 21 times -1. After this, you'll have 6 plus 23i, and now you'll have minus 21. Now you're just going to combine like terms again. -21 plus 6 will give you -15, and then you're left with the plus 23i, which is your answer. Dividing complex numbers, the first thing you have to do is multiply by the conjugate. To find the conjugate, all you do is change the sign between the two terms of the denominator. So it would look like this. Instead of 2 plus 3i, it would be 2 minus 3i, divided by 2 minus 3i. So using FOIL, you'd first multiply 3 times 2, which is 6, then 3 times -3i, which would be -9i, then 7i times 2, which is 14i, and then 7i times -3i, which is -21i squared. Then, for the bottom, 2 times 2, which would be 4. 2 times negative 3i, which is negative 6i. 3i times 2, which is positive 6i. And then 3i times negative 3i, which is negative 9i squared. You have to simplify all powers of I. So this includes where I is squared, right here. So it would look like this. The only difference between these two equations is that the power of I is simplified to being negative 1. Simplify these parts right here of the expression. This would give you 6 minus 9i, 18i, minus, well actually now it'll be a plus 21, since you multiply negative 21 times negative 1, over 4 minus 6i plus 6i, and now this will be a plus 9. Now you can actually combine your like terms, which will equal 6 plus 5 plus 21 over, 5i actually, over 4, and these will cancel each other out, so this is supposed to be 4 plus 9, which equals 27 plus 5i over 13. So we want this answer to be written in the form a plus bi. So it would look like this. 27 over 13 plus 5 over 13i. And this is your answer.